Hello and welcome to more chapter 6, more diagrams. We're going to take a look today in what a so-called histogram is and what a stem and leaf diagram is. Okay, we're going to take a look at histograms first, and there are quite some new glossary words here as well. To introduce them to you, let's take a look at this example that the book gives you. A football trainer kept a record of how many corner kicks his team took per match during a competition. 3446376544364654. This is not very um, comprehensive, right? You can take a look at this and say, well, okay, these are numbers, but I don't see in one go how many threes are there, how many fours are there, etc. So to get a good overview of this data, of those results, you can make a table. To do that, in the first column, you put the data values, waarnemingsgetallen wordt het ook wel genoemd, and that are in this case the number of corners. And next you make a tally. In Dutch we call this turven. So if we do that, we can sketch this table here, 3, 4, 5, 6, 7. I don't write down 0, 1, and 2 because I quickly can see that those numbers are not in my data value set, and also not more than 7 because I don't see more than 7 appearing either. And then you just tally them, right? So 3, 1, 4, 1, not a 4, 1, 6, and then you do that until you find the total so-called frequency. And in Dutch this is just called the frequentie. Betekent hoe vaak iets voorkomt. In English you can say the data value 4 occurs 6 times. A frequency shows how often a data value occurs. This is a table that you can make, but oftentimes you will see those tables called frequency tables more in this form right here, where there is not a tally column, you can say, and instead of vertical like this, they're horizontal. So if you take a look at this, the number of corners 3, the frequency of that is 4. That means there were 4 matches in which there were 3 corners. There were 6 matches in where there were 4 corners, 2 matches with 5 corners, 5 matches with 6 corners, and 1 with 7 corners. Okay? So a frequency table consists of a row of data values and the corresponding frequencies, like this. And if you now want to make this a bit more visually appealing, you can say, oftentimes what we do is we make a histogram out of this data. So what we do is we take this data and now convert this into an actual diagram. How do we do that? Well, you again set up your diagram. We have a vertical axis, we have a horizontal axis right here. Again, give it the title, write down what the axes do. And this looks a lot like a bar chart, right, which we discussed in 6.2. Only a histogram is a bar chart for a frequency table. Dus een histogram, Nederlands een histogram, dat is hetzelfde, is eigenlijk een staafdiagram die bij een frequentietabel hoort. En er is één groot verschil, wat je misschien ziet, en dat is dat er geen ruimte is tussen de staven. There is no gap between the bars. And with an histogram, oftentimes underneath there are also just numbers, right? So 1, 2, 3, 4, 5, 6. And now you can see quite quickly that the number 3 occurs 4 times. Number 4 occurs 6 times. That's the frequency, right? And this is what we call a histogram. Okay, clear? Then now we will take a look at a new one, a so-called stem and leaf diagram. For a stem and leaf diagram, we often use this kind of diagram when we have data, for example, like this. If you have those frequencies here, or those, no, sorry, not frequencies, if you have those values right here, those data values, don't make a frequency table out of this, please, because then you get something like this, and I already cheated here because I left out the number 0, 1, 2, 5, 6, 7, 9, 14, 15, 16, 17, 20, etc. Otherwise, this table would be even longer, and we got a frequency table with a lot of zeros in them as well. Even if I leave out my data values that have a frequency of 0, I still have a very long frequency table, which doesn't provide me much insight of what actually is happening right now. Don't do this. Don't make frequency tables when you have a long list of data values in a large if there are much, start the sentence over. Don't make a frequency table when your data values are far apart from each other and they don't occur that often. That's what I wanted to say. Then we make a stem and leaf diagram. And my personal experience is that this is the most confusing one at first. So I'm trying to explain this using a few steps on how this works. En de name stem en leaf diagram, in Dutch een steel-bladdiagram, doet een beetje denken aan een bloem met een steel en een blad eraan. How we're going to do that, we're going to separate each data value into two parts. The first number, oftentimes in the second number, or the so-called stem and leaf, het steel en het blad. That's going to be very abstract, so just show how you're going to do that. You're going to make two columns. Here are the speeds that were measured, or use something different. This is what belongs to this example here. Let's say these are the data values, and we're going to make a stem and leaf diagram here. Make columns, and to do so, we're going to split this number into two parts. The first number, the tens, and the second number, the units, the tientallen and the eenheden. So for example, 72 has the stem, the tens are 7, and the units are 2. Here, the stem is 6, the leaf is 3. The stem is 5, the leaf is 9. If you take a look here, all the stems are from 5 up to and including 8. So that's why my stem, my tens here, go from 5 up to and including 8. Now we're going to write down our actual data values by using our unit system to the right as well. What you're going to do is you're going to now write down the leaves in the second column. For example, the number 72 gives you leaf 2, the stem was 7, so here is the data number 72. 73, then my stem, my tens is 6, and my leaf is 3, so here's the number 63. So which numbers are there now in my stem and leaf diagram? Here is 59, then is 58, then 57, then 59, and 55. You see, I combine my tens with the number that's in my unit column. I combine my stems with my leaves. Here, 63, 65, 67, 64, 63, 61, 72, 74, and 70. And last but not least, we have one value that is 80, 8 with a 0. Okay? The only problem is, if you do it like this, now you just followed this in order, right? So we first would write down 72, 7, 2. Then 63, 3 here. 59, 9 here. 8 here. 0 here. Now they are not in order here. So what we now would do, this would be your sketch, you can say, to make this more make this thing more valuable to us, to give it more insight. I'm now going to write them like this, but the leaves in order from smallest to largest. So here, just put them in order, right? 5 first, then 7, then 8, then 9, then 9. So the same data values are represented, but now in order from smallest to biggest. Here as well, and here as well. Write down, that's the first thing that you already did, that these are the tens and these are the units. And also write down what we are talking about. In this case, speeds. I would write down speeds in kilometer per hour, but who am I to judge the book? I would be a bit more elaborate than just speeds, but okay. Don't forget the title. And this is a stem and leaf diagram, and this oftentimes looks a bit difficult. What you're going to do in the project, First of all, you just get a stem and leaf diagram, and we're going to analyze data in it. For example, what is the smallest data in this stem and leaf diagram? Well, in this case, that's 55, right? What's the biggest? 8 and 0, so the biggest is 18. Which data value occurs twice? Well, in this case, there are two. 59 occurs twice, and 63 occurs twice. Can you give me a number that doesn't occur? Well, for example, 81, because there's no 1 here as a leaf if my stem is 8. Okay. What you sometimes also see is a so-called double stem and leaf diagram. And this one can be quite weird to read. If you have something like this, we have the stem in the middle and we have leaves to the left and to the right. For example, if I take a look at this data value here, and be careful, here we're talking, for example, about units and tenths. Dus nu zijn hier de eenheden en hier de tienden. So this is 10.6. Here, this purple one is not 5.11, right? Because my stem is 11. Here, this is data point 11.5. Be careful with that. And here, for example, we have 12.0, 12.0, and 12.8. Here, 13.1, 13.5 for the men, and 13.0, 13.1, 13.5, and 13.6 for the women. And sometimes you will see that we just skip a stem. So for example, there are no values with stem 15. So in this context, that means there are no hourly wages for either men or women that are 15 euros and something. The next one will be 16 euro and 30 cents. Okay, so that's a double stem and leaf diagram. And now the last thing, and this is new this year, we're going to take a look at class intervals, naar klassen. And class intervals can often help us when we have a large data value that has a large width, we call that. So we have large numbers going from, for example, 0 up to and including 60. Yeah, then sometimes you can use class intervals to put that data into an histogram either way. How you do that, we're now going to categorize numbers into certain classes. For example, in the class 0 and then this sign 10, 0, 10 I will just call this, are all data values from 0 up to, but not including 10, right? So in this case, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And also 9.8, 9.9 if data it gives values like that, but not 10 itself. This is 10 up to, but not including 20, 20 up to and including 30, 30 up to and including 40, etc. Dit gives us a so-called frequency distribution. In Nederlands is het een klassenindeling. De Engelse vertalingen zijn vrij moeilijk in dit gedeelte. In het Nederlands hebben ze overal over klassen. En hier hebben we, ja, de woorden zijn ietsjes lastiger. This thing gives us a frequency distribution. That's this whole thing altogether. This whole table is called the frequency distribution. The class intervals are the things here on the left. So 0 up to but not including 10 is a so-called class interval. For this class interval 30 and 40 are the class boundaries. De class boundaries zijn de klassegrenzen. Dus de grenzen hiervan zijn 0 tot 10, 10 tot 20, 20 tot 30. De interval width, de klassebreedte, is in dit geval 10, maar ook van 0 tot 10. The advantage of frequency distribution is that we can now make an histogram of this quite elaborate and maybe quite big data sets from 0 up to 60, because all numbers from 0 to 10 are now going to be combined in one bar, you can say. This bar now contains all the values from 0 up to 10. This bar includes all from 10 to 20. A disadvantage of a frequency distribution is that if you only have a frequency distribution, you cannot quite well see which numbers are inside of this class, right? If a frequency of 4 Yeah, this class can consist of the numbers 1, 2, 3, 4, but also of 4, 5, 6, 7, and even of 9999, right? You don't know that. So you know how many numbers are inside of a class, but you don't know which numbers. You should know the difference now at the end of this paragraph between a disting, a frequency table with an histogram, and a frequency distribution with a histogram. Here, all numbers have a frequency, and now we can set them out in a histogram. You see, this is very accurate. The number 3 occurs 4 times. The number 4 occurs 6 times. This is nice and well if we have data values that are quite close to each other and occur, well, quite often as well. But if I have a very large or a very wide data set, for example, from 0 to 60, and every number only occurs 1 or 2 times, then sometimes you don't, well, not sometimes, you don't use a frequency table and histogram because we get such a large histogram and such a large frequency table. Now use a frequency distribution like this, right? And one small thing that you have to notice is that because a frequency table and a histogram, we in this bar there are only the number 3. That means that the number is underneath that bar, right? Here, because this bar occupies every number from 0 to 10, it is now in between the numbers. You see that the numbers here are underneath the bars and here are on the grid lines, so you can see between the bars. It's quite a difference, right? So this histogram looks a bit differently. I'm going to compare it to this histogram. So use this one when your data set is nice and close together. Use this data set when your data set is not nice and close together, and when you have a lot of data values that only occur once or twice or 0 times. Then this thing is a lot more comfortable to use. Okay, a lot of new glossary words, right? These are all things with frequency tables and histograms. This is about stem and leaf diagrams, and here the words that are belonging to class intervals and frequency distributions. Good luck, and I will see you for the next video.